Let's take a look at this hypothesis testing problem involving a proportion. A credit rating system is deemed to be satisfactory if it correctly assesses at least 80% of the bank's customers. Unfortunately, in a sample of 1,000 clients, only 740, which is 74%, were correctly assessed. Is this enough information to think that the credit rating system is satisfactory? Okay, so the null hypothesis will be that pi is 0.8. Or if it's greater than 0.8, that's fine with us also, but we'll take pi to be equal to 0.8. And the alternative is that this is not due to chance, so that pi is less than 0.8. Okay, this is a proportion problem, which means I will be using the z-test. Z equals the observed proportion, which is 0.74, 740 divided by 1,000, minus the expected proportion, divided by the standard error for the proportion. Now let me mark over here in red that this is a proportion problem, so the standard error for the proportion is pi times 1 minus pi over n. Now notice in this problem I do have a hypothesized value for pi, 0.8. So when I figure out the standard error for the proportion, I need to use 0.8 in the square root and not 0.74. So that's a slight difference between a proportion problem versus the average problems that we've seen in the past. Here I have a hypothesized value for pi, so I will use that value of pi and plug that in for my exact standard error. Okay, so I get a z value, which is equals 0.74 minus 0.8 divided by the square root of 0.8 times 0.2 over 1,000. So that works out to be negative 4.743. So if we figure out the p-value, the area to the left would be norm s dist of the number we just got, which is about 1 chance in a million. So if we believe the null hypothesis, then we also have to believe that something that had only 1 chance in a million of happening just happened. That's possible, but it's not plausible, and so our decision will be to reject the null hypothesis. The other way of doing the problem would be to figure out the critical value. So let me do that up here in the upper left-hand corner, or upper right-hand corner. The critical value would be bell curve, and we figure out the value of z so that the area to the left is equal to alpha, and we'll take our default value of alpha to be 5%. So for this problem, the critical value is equal to norm S inv of 0.05, so that 5% of the area lies to the left. So the critical value works out to be negative 1.6448, or 4485. The test statistic z falls well inside of this rejection region, and so our decision is to reject the null hypothesis. We reject the null hypothesis. We have reason to believe that the system is unsatisfactory. And so that concludes this hypothesis testing problem using a proportion and the bell curve.